everyone, welcome back to my channel. In today's video, we are going to learn how to implement RSA encryption and decryption algorithm in Python using socket programming. In this video, we will cover what RSA is and why it is important, real world applications of the RSA algorithm, step by step explanation of our Python code, and live demo of encryption and decryption over a network socket. So let's first understand that what is RSA algorithm. So basically RSA stands for Rivest Shamir Eldman, named after its inventors, and it is one of the most widely used public key cryptographic algorithm, and it is a asymmetric algorithm where we require two keys, public key for encryption and private key for decryption. This means you can share your public key with anyone, and only you with your private key can decrypt the message. Okay, RSA is everywhere in our daily digital life, but here are the some key applications of the RSA algorithm. RSA is used for secure data transmission. It is also used for the digital signatures to verify the authenticity of documents and softwares. RSA is a backbone for securing the website and online banking by providing the SSL and TLS certificates. It protects messages from unauthorized access for email encryption, and it is also often used to exchange key for faster algorithms like AES. So today we will focus on secure data transmission over socket. So let's start the server side code, and for that you have to first import the necessary Python libraries. So we have to first import socket for the network communication, RSA and PKCS 1 underscore OAEP from PyCryptodome from RSA encryption and decryption, base 64 to encode and decode data safely for transmission. So let's first generate a 2048-bit RSA key pair. This gives me both the private and the public keys. Okay. Then I export the private key for decryption and the public key for the encryption. Okay. So for that, you have to write that RSA dot import underscore key private key, and decrypt for the decryptor you have to use the pkcs 1 underscore oaep dot new for this RSA key. Okay. Now you have to create a TCP socket to bind it to the local host on the port number 12345, and start listening for the incoming connections. Okay. uh, then you have to print that server is listening on this port number. Now you have to accept the connection. For that accept method, wait until a client connects and then stores the connection in con and the client address in address. Okay. Now I need to send a public key to the connected client so that they can encrypt a message for me. Okay. So after that, I received the encrypted message sent by the client, and it's a base 64 encoded. Now I decode the base 64 string to get back to the original encrypted bytes. I create a PKCS OEP cipher object with my private keys so that I can decrypt the message. Okay. Now I decrypt the encrypted message and get the original plain text. Okay. So you need to check that while we're sending data in the socket, the data must be encoded, and after receiving that, we have to decode the message to get the original message. Okay. Now I am printing the decrypted message, that is a plain text. Okay. Now we have to close the connection and shut down the server. So in this way, we can develop the RSA server side code. Okay, so let's start the RSA client side coding, and for that you have to import the same library as in the server code for encryption, decryption, and the networking. Okay. Now, in the client side, we have to first create TCP socket, and for that you have to connect same as in the server to connect with the local host and port number 12345. Make sure you have to connect with a TCP socket. Okay, and for connection you can write socket dot connect and print that you have connected to the server. Okay. Now you have to client have to first receive the public key from the server, and this public key has the size 2048 bits, and this will be used for the encryption. Now you client has to create a PKCS one underscore OEP cipher object using the received public key. Okay, so that this key can be used for the encryption. Okay. Now after encrypt means key, after key you have to prepare a message. For that you have to take input from the client, and you have to client has to encrypt the message using the public key, and client use the base 64 encode to encode the encrypted message, so it can be sent safely over the socket. Okay. Now client send the encrypted data to the server and close the socket connection and print that encrypted message sent to the server. Okay. So in this way you can develop client side code for RSA algorithm. So after developing both the client and the server side code, let's check the live demo that how the message is encrypted and sent to the server, and at the server end how the message is decrypted. So for that you require a two terminal, one for the server and one for the client. So first I run this server side code in console. You can see that server is listening on port number 6000. Now in the another terminal I run this uh, client code. You can see that connected to the server, and after connection it receives the public key from the server. Now I write hello, welcome to my channel as a message and press enter. It gives that this message is encrypted and sent to the server. Now at the server console you can see that this encrypted message is received, and after decryption this is the message. Okay. So in this today's video we learn what RSA is and how it works, real world applications of RSA, and how to implement RSA encryption and decryption in Python using the socket programming. So if you found this tutorial helpful, please give it a thumbs up, share it with your friends, and don't forget to subscribe for more programming and cybersecurity tutorials. So thanks for watching, and I will see you in the next video. Thank you.